We now discuss the solution of a problem from the section Trigonometry. This given question is based on the computation of the number of solutions of a given trigonometric equation in a given interval. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is the number of elements in the set S is equal to the set of all theta belongs to the closed interval minus 4 pi to 4 pi such that 3 cos square 2 theta plus 6 cos 2 theta minus 10 cos square theta plus 5 is equal to 0 is. Now we are given a trigonometric equation. This trigonometric equation. We are asked to find the number of values of theta that belongs to the closed interval minus 4 pi to 4 pi which satisfy this trigonometric equation. We now discuss the solution of the problem in detail. We are given the trigonometric equation 3 cos square 2 theta plus 6 cos 2 theta minus 10 cos square theta plus 5 is equal to 0. We take this equation and we write for 2 cos square theta 1 plus cos 2 theta. That means we write 1 plus cos 2 theta for 2 cos square theta in this equation. Then the equation becomes minus 5 times. This 10 times cos square theta is minus 5 times 2 cos square theta. That is for 2 cos square theta we have written 1 plus cos 2 theta and the remaining terms are same. Simplify. After simplification we get 3 cos square 2 theta plus cos 2 theta is equal to 0. Factorize. Cos 2 theta multiplied by in brackets 3 cos 2 theta plus 1 is equal to 0. This will imply cos 2 theta is equal to 0 or 3 cos 2 theta plus 1 is equal to 0. This implies cos 2 theta is equal to 0 or cos 2 theta is equal to minus 1 by 3. So, therefore, this the above set S is the set of all theta belongs to the closed interval minus 4 pi to 4 pi such that cos 2 theta is equal to 0 or cos 2 theta is equal to minus 1 by 3. We write it as the union of two sets S1 union S2 where S1 is the set of all those solutions of the equation cos 2 theta is equal to 0 in the interval minus 4 pi to 4 pi, that is S1, and S2 is the set of all those solutions in the interval minus 4 pi to 4 pi which satisfies the trigonometric equation cos 2 theta is equal to minus 1 by 3. And notice that no solution of cos 2 theta is equal to 0 is a solution of cos 2 theta is equal to minus 1 by 3. So to speak, that there is nothing common between the sets S1 and S2. That is, the intersection of S1 and S2 is empty. Those now required to find the number of elements in the set S, that means required to find n of S. So n of S is equal to n of S1 union S2 and that is equal to n of S1 plus n of S2 because S1 intersection S2 is empty. Agreed. We compute n of S1 and n of S2 in the next slide and then compute n of S. So we consider two cases. Case 1, S1 is equal to the set of all theta belongs to the interval minus 4, closed interval minus 4 pi to 4 pi which satisfies the trigonometric equation cos 2 theta is equal to 0. And in case 2, we consider S2 is the set of all those solutions in the interval minus 4 pi to plus 4 pi which satisfies the trigonometric equation cos 2 theta is equal to minus 1 by 3. Now we attempt first S1. Now cos 2 theta is equal to 0 will imply 2 theta is equal to 2n minus 1 pi by 2 n belongs to z. This is the general value. And theta will be equal to 2n minus 1 pi by 4 n belongs to z. And if you take n is equal to 1, you get pi by 4. N is equal to 2, 3 pi by 4. Like that, n is equal to 8, you will get 15 pi by 4. And cos theta is same as cos of minus theta. Therefore, whatever values, the 8 values what we got earlier, we take with their minus sign also, they will also work. Therefore, S1 is equal to the set of all those values plus or minus pi by 4, plus or minus 3 pi by 4, plus or minus 5 pi by 4, etc. up to plus or minus 15 pi by 4. Very clearly, these are the plus signs are 8 and minus signs are 8, and these are 8 plus 8, 16 in number. So therefore, n of S1 is equal to 16. In a similar fashion, we will also compute what is n of S2, where S2 is the set of all those solutions of the equation cos 2 theta is equal to minus 1 by 3 that lie in the interval, closed interval minus 4 pi to plus 4 pi. Agreed. Now, we look at the graph of cos 2 theta, and we notice that there are two values of theta that belongs to the interval 0 to pi, for which cos 2 theta is equal to minus 1 by 3. So there are exactly two values of theta belongs to in this interval 0 to pi, for which cos 2 theta is equal to minus 1 by 3, and you can see it from the graph, and this is your cos 2 theta graph, and this is theta is equal to 0, and this is theta is equal to pi. Theta is equal to pi. In that the cos 2 theta is equal to minus 1 by 3. So there will be two values of theta in this interval such that cos 2 theta is equal to minus 1 by 3. So this is one, this is the other. This is the other. And this is in the interval, this is the situation in the interval 0 to pi. And further note down what is the cos 2 theta period, because it is a periodic function. Cos theta period is 2 pi. Therefore, cos 2 theta period is 0 to pi. 0 to pi. So we take in 0 to pi, and in every 0 to pi 2, and pi to 2 pi 2, 2 pi 2, 3 pi 2, like that. The four arches will be there. 4 arches will be there, and in the negative direction, 0 to minus pi to 0, minus 2 pi to minus pi, so on and so forth. So in all, in this, since the period of cos 2 theta is 0 to pi, and there will be 8 into 2. So 8 arches will be there. 4 to the right, 4 to the left, and in each 2, so 4 2s are 8, 8 into 2. So that is 16 values of theta that belongs to minus 4 pi to plus 4 pi, for which this equation cos 2 theta is equal to minus 1 by 3 is satisfied. So n of S2 will be 16. Now we have already seen n of S is equal to n of S1 union S2 is equal to n of S1 plus n of S2, that is equal to 16 plus 16, that is equal to 32. So therefore, the required answer for this question is n of S is equal to 32. That is the detailed discussion of the solution of the problem from the section trigonometry, which is based on the number of solutions of a given trigonometric equation in the given interval. And it is definitely an easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.